You just had a birthday. Maybe you didn't think much of it. Maybe you blew out candles, ate cake, scrolled past a few messages. But if you had been born 40,000 years ago, that birthday might never have come. Not because of some dramatic accident, not because of war. Because for most of human history, simply living past 30 was the hardest thing a person could do. You've probably heard the number before. Life expectancy in prehistoric times around 30 years old. It gets repeated so often that it stops sounding strange. But sit with it for a second. 30. That's barely old enough to have grandchildren. That's an age where, today, many people are just starting their careers. So what happened back then? Were ancient humans just built differently? Weaker? Fragile? The real answer is far stranger than that. Ancient humans weren't dying of old age at 30. Most of them weren't dying of age at all. The number 30 is an average. And averages lie. Think about how strange it is that we even trust that number so easily. Nobody carried a birth certificate 40,000 years ago. Nobody logged their exact age in a ledger. So where does the number 30 even come from? It comes from bones, from teeth, from the patient, painstaking work of scientists piecing together thousands of skeletons and estimating, as precisely as they can, how old each person was when they died. And when you add up all those ages and divide by the number of skeletons, you land somewhere around 30. That's real math. But it is answering a very different question than the one most people think it's answering. Here's what actually happened. Imagine a village of 20 people. 10 of them live long, healthy lives dying at 60 or 70. But 10 others die as infants, before their first birthday. Add those ages together. Divide by 20. You get an average age of death around 30. But notice something. Nobody in that village actually died at 30. The average erases the truth. It hides two very different stories inside one deceptively simple number. This is the first crack in the myth. Ancient humans were not uniformly short-lived. They were bimodal. Their deaths clustered into two extremes. A massive wave of death in infancy and early childhood. And then, for the ones who survived that wave, a real shot at living into their 60s, 70s, even 80s. Why does this matter so much? Because it changes the entire emotional story you tell yourself about the past. A world where everyone dies around 30 is a world of universal fragility, where nobody has time to grow old, fall in love twice, watch a grandchild take their first steps, or become the wise figure in a story passed down for generations. But a bimodal world is different. It's a world of extremes. Devastating loss on one end, genuine longevity on the other, and almost nothing in between. That's a much stranger, much more human story than the flat, simplified version most people carry around in their heads. Researchers have known this for decades, but it took anthropologists studying real skeletal remains to prove it clearly. In 2007, researchers Rachel Caspari and Sang He examined thousands of fossilized teeth from human and Neanderthal remains across hundreds of thousands of years. Teeth are remarkably good clocks. Their wear patterns reveal roughly how old a person was when they died. What Caspari and Lee found reshaped the story of human aging entirely. Older adults weren't rare in prehistory. They existed. In fact, the ratio of older adults to younger adults appears to have significantly increased around 30,000 years ago, right around the time modern humans were flourishing across Europe. Grandparents weren't a modern invention. They were there, watching, teaching, surviving. What made this finding so significant wasn't just that old age existed. It was the timing. Caspari and Lee noticed that as the ratio of older individuals increased, something else changed alongside it. Cultural complexity seemed to expand too. More sophisticated tools, more intricate art, wider trade networks between distant groups. It's tempting, and many researchers find it compelling, to connect the dots. More surviving elders may have meant more accumulated knowledge circulating through a population at any given time, more skilled teachers available to pass down complex techniques, more grandparents available to free up younger adults for innovation instead of pure survival. Longevity, in other words, may not have just been a side effect of human success. It may have been one of the engines driving it. This finding also quietly demolished an older, much bleaker assumption that had lingered in anthropology for decades: the idea that Neanderthals and early humans simply had short, brutal lives across the board, with almost nobody living past their 30s under any circumstances. The tooth data told a different story. Old age wasn't common, but it wasn't a fluke either. It was a real, recurring part of the human experience, stretching back tens of thousands of years before the first written word. So why does the myth of the 30-year lifespan persist? Because infant mortality was catastrophic. Truly catastrophic in a way that's almost impossible to imagine today. Estimates suggest that in many prehistoric populations, somewhere between a third and half of all children died before reaching age 5. Childbirth itself was a battlefield. Without modern medicine, without antibiotics, without sterile environments, a difficult labor could kill both mother and child in the same afternoon. Fevers that a modern person would barely notice could spiral into deadly infections. A simple cut could turn septic within days. Modern researchers studying contemporary hunter-gatherer populations, groups whose lifestyles remain closest to how humans lived for most of history, have found similar patterns that help validate what the fossil record suggests. Anthropologists Michael Gervin and Hillard Kaplan compiled mortality data across dozens of small-scale societies and found a strikingly consistent pattern: extremely high mortality in the first years of life, followed by a dramatic drop in risk once someone survived into their teenage years. Their research helped confirm that the ancient pattern wasn't unique to one region or one time period. It appears to have been a near-universal feature of life before agriculture and modern medicine, showing up again and again across radically different environments, from deserts to rainforests to Arctic tundra. Picture it for a moment. You are a parent 40,000 years ago. You have 5 children. Statistically, you should expect to bury 2 or 3 of them before they grow old enough to have their own children. That is not a tragedy that strikes once in a lifetime. That is the ordinary shape of a life. Grief wasn't an interruption to daily existence. It was woven into it. And it wasn't only children at risk. Mothers themselves were gambling with their lives every time they gave birth. There was no way to detect a breech position in advance. No way to perform an emergency surgical delivery if labor stalled. No blood transfusion if hemorrhaging began. A woman giving birth was, in a very real sense, walking into one of the most dangerous moments of her entire life, again and again, every time she chose to have another child. Anthropologists estimate that maternal mortality in many prehistoric populations may have been staggeringly high compared to today, likely in the range of 1 to 2% per birth. And remember, women weren't giving birth once. They were giving birth 5, 6, 7 times across a lifetime. Multiply that risk out, and you start to understand why so many groups depended on more than one adult woman to keep children alive. A single point of failure was too dangerous to rely on. Weaning made things even more precarious. A nursing infant, protected by antibodies passed through breast milk, was relatively insulated from the microbial world around it. But once a child was weaned, usually somewhere between 2 and 4 years old, that protection vanished. Suddenly, the child was eating the same food, drinking the same water, touching the same soil as everyone else, with an immune system that had never been tested against any of it. This is why so much early childhood death didn't happen at birth. It happened in that vulnerable window right after weaning, when a toddler's body was essentially meeting the world for the first time with no training at all. Why? What made early life so lethal? 3 forces working together relentlessly. The first is disease. Not the diseases you think of today, necessarily. Many of the plagues and pandemics we associate with history, smallpox, measles, tuberculosis, actually emerged later, after humans began living closely with domesticated animals and in dense agricultural settlements. Before that shift, prehistoric humans faced a different set of threats: parasites, bacterial infections, gastrointestinal illnesses from contaminated water, and wounds that had no way of healing cleanly. A body without immunity built up over generations, without medicine, without understanding of germs, was extraordinarily vulnerable. A stomach bug that might cost you a day of discomfort now could kill a child within a week back then. The second force is malnutrition. Food was inconsistent. A single bad season, a drought, a failed hunt could mean weeks of hunger. Children are especially vulnerable to malnutrition because their bodies are still building bone, brain tissue, immune defenses. A malnourished child isn't just smaller. Their entire biological system becomes fragile, less able to fight off the diseases that were already stalking them. There's a particularly telling clue hidden inside ancient teeth called enamel hypoplasia. These are small bands of thinner, weaker enamel that form when a child's body is under severe stress while their teeth are still developing, usually from starvation or illness. When researchers examine prehistoric skeletons under a microscope, they can often see these bands and estimate, almost like reading tree rings, exactly how old a child was when they went through a period of serious hardship. Study after study has found these stress bands are remarkably common in prehistoric remains, sometimes appearing in the majority of individuals examined, It's physical, permanent proof, written directly into the body, of just how frequently early life involved genuine physiological crisis. The third force is trauma, physical trauma. Falls, animal attacks, accidents while foraging or hunting, violence between groups competing for resources. Anthropologist Stephen Churchill and others who study skeletal remains have documented healed fractures across ancient skeletons that reveal just how physically dangerous prehistoric life could be. Notice the word healed. Many injuries didn't kill immediately. They killed slowly through infection, through complications, weeks or months later. Consider what a broken leg actually meant back then. Today it means a cast, some crutches, maybe 6 weeks of mild inconvenience. 40,000 years ago, it could mean you could no longer walk with the group when they moved to follow food. It could mean weeks of being unable to forage for yourself. It could mean the wound around the break, however small, becoming infected with no way to clean it properly. A single fall from a tree, a single kick from a wounded animal, a single sharp rock in the wrong place, could set off a chain reaction that ended in death months later, far removed from the original injury. The body was resilient, but the margin for error was razor thin. Put those three forces together, disease, hunger, trauma, and you get a filter. A brutal filter that life had to pass through in the first 5 years. Survive that filter, and your odds improve dramatically. Survive childhood, survive adolescence. Survive your first pregnancies if you were a woman, and you had a real chance at what we would recognize as old age. This is where population data becomes genuinely surprising. Demographers who study small-scale societies, both ancient and modern hunter-gatherer groups, have found something consistent. Once a person reached about 15 years old, their remaining life expectancy jumped dramatically. A 15-year-old in a prehistoric population might reasonably expect to live into their 50s or 60s. That's not so different from many parts of the world just a couple of centuries ago. The danger was never evenly spread across a lifetime. It was concentrated, almost violently, into the earliest years. This is where the story gets even more interesting, because surviving wasn't just about biology. It was about grandparents. There's a concept in anthropology called the grandmother hypothesis, developed significantly through the work of anthropologist Kristen Hawkes, who studied the Hadza people, a modern hunter-gatherer society in Tanzania, as a living window into ancient human behavior. Hawkes noticed something curious. Human females, unlike almost every other mammal on Earth, live for decades after they're no longer able to reproduce. Menopause is strange, evolutionarily speaking. Why would natural selection allow a body to keep living long after it can no longer pass on genes directly? Hawkes' answer reframed the entire conversation. Grandmothers weren't a biological afterthought. They were a survival strategy. Older women who could no longer bear children could instead gather food, care for grandchildren, and free up mothers to have more children sooner, spacing out pregnancies while still keeping the whole group fed. A grandmother wasn't a burden on the tribe. She was often the reason her grandchildren survived long enough to have children of their own. Elders weren't decorative. They were infrastructure. This changes the entire emotional picture of prehistoric life. It wasn't just brutal chaos where nobody got old. It was a system, harsh and unforgiving in its early stages, but one that rewarded survival with community, wisdom, and continued contribution. The elders who made it through were often the most respected members of a group, not because of sentimentality, but because their knowledge. Which plants were poisonous, where water could be found in a drought, how to treat a wound, had been proven, tested, and trusted across decades. Think about what an elder actually represented to a small group of 30 or 40 people. They weren't just an extra pair of hands. They were a walking archive. Before writing existed, before any way to record information outside a human mind, the only way knowledge survived from one generation to the next was through people who remembered it and were still alive to pass it on. An elder who remembered a drought 40 years earlier. And how the group had survived it could be the difference between panic and a plan when the next drought came. An elder who had watched a child recover from a particular illness using a particular plant could save a life decades later using nothing but memory. Longevity wasn't just a personal achievement. It was a form of insurance for the entire group. This is also why the loss of an elder could be so devastating to a small community, in ways that go beyond grief. Losing an experienced hunter, a skilled toolmaker, or someone who simply remembered where the emergency water sources or could genuinely threaten the survival of everyone else. Groups that managed to protect and support their older members, even when those members could no longer contribute physically, appear to have had real survival advantages. This wasn't charity, it was strategy, even if nobody would have called it that at the time. So if elders existed, if survival past childhood meant a real chance at old age, why does modern life expectancy still look so different? Why do you, right now, expect to live into your 70s or 80s as a near default? The answer isn't really that human biology changed all that much. Your body, genetically, isn't dramatically different from a human born 50,000 years ago. What changed is the filter. Modern sanitation removed the contaminated water. Vaccines and antibiotics removed most of the deadly infections. Modern obstetric care turned childbirth from a coin flip into something statistically safe in most parts of the world. Food distribution systems, imperfect as they are, largely removed the seasonal famines that once devastated small groups. You are, quite literally, alive today largely because the deadly filter of infancy and early childhood has been almost entirely dismantled by public health. This is the modern mirror, and it's worth sitting with. Every time you drink water from a tap without a second thought, you are bypassing a threat that once killed a significant percentage of every generation before you. Every vaccine a child receives today is closing a door that used to be wide open to death. You don't think about this because you don't have to. That is not a small thing. That is one of the great, invisible triumphs of the last 200 years. Consider how recent this shift actually is. 200 years is nothing on an evolutionary timescale. It's a blink. For roughly 99% of the time humans have existed as a species, the filter of early childhood death was simply how life worked, everywhere, for everyone. There was no country on Earth exempt from it, no culture that had solved it. Then, within a handful of generations, a combination of sanitation engineering, germ theory, vaccination, and modern medicine dismantled a threat that had shaped human existence since the very beginning. Your grandparents, or your great-grandparents, may have lived through the tail end of a world where losing a child was still tragically common. Your own existence, right now, reading this, is downstream of that dismantling. Somewhere in your family line, at some point, a child survived an illness that would have killed them a century earlier. And that survival is part of why you exist at all. It also explains something strange about how humans think, something worth pausing on. Your brain biologically wasn't built for a world of tap water and antibiotics. It was built for a world of constant, immediate threat to children. That is why parental anxiety runs so deep, so instinctively, even today, even in the safest environments humanity has ever created. A parent who feels a spike of fear when their child coughs unusually or wanders too close to the edge of a playground isn't being irrational. They're running ancient software, tuned across hundreds of thousands of years to a world where that fear kept children alive. The world changed far faster than the wiring did. But here's the twist worth remembering. Ancient humans, if they made it past childhood, were not fragile husks limping toward an early grave at 30. Many of them lived rich, long lives. They raised grandchildren. They passed down stories, skills, warnings, and wisdom across decades, the same way you might learn something from an older relative today. The image of the prehistoric human as someone who was old and worn out by their 30s is largely a myth built on a misunderstood average. What actually happened is more human, more relatable than the myth. Life was fragile at its beginning and precious because of it. Every child who survived infancy represented not luck alone, but the accumulated knowledge of a group working to keep them alive. Every grandparent who lived to old age represented decades of surviving disease, hunger, and danger, and then spending those hard, years making sure the next generation had a better chance than they did. There's a kind of quiet dignity in that picture that the old myth completely erases. It wasn't a world of short, brutish lives ending uniformly in the prime of youth. It was a world where survival itself was the achievement, where every year gained past childhood was hard-won, and where the people who made it through carried that hard-won knowledge forward for as long as their bodies allowed. The 30-year-old average was never a ceiling on human potential. It was a scar left by an era before medicine existed, a number that measured loss far more than it measured how long a life could actually last. And maybe that's the real lesson buried inside that misunderstood statistic. Longevity was never actually rare in human history. Surviving long enough to reach it was the rare part. So the next time you blow out candles on a birthday, on the exact kind of ordinary day that would have felt like a small miracle 40,000 years ago, remember what that number actually represents. not fragility, not an ancient world doomed to die young, but a species that fought generation after generation, grandmother after grandmother, to make sure that someday, a birthday like yours wouldn't be miraculous at all. It would just be Tuesday.